Hello from Ohio and welcome. A few years ago, one of my secretaries jokingly gave me a purchase order for a ridiculously expensive waterfall feature for a wall in our office. I decided our nonprofit probably didn't need a wall decoration that cost more than $1,000, but we did need something for that wall. What I came up with might not have water, but I think it'll fit the wall nicely. You don't have to be a professional engineer, a computer programmer, or product design specialist in order to make some really cool things on your own. Let's learn how to do it together on Just Making It with Josh. In thinking about what would be nice for the wall in our office, I really wanted something that was customized for us. I wanted it to be uniquely ours. I also wanted something that was lighted. I'd seen videos of these Nanoleaf panels and I really liked the way they looked. I took inspiration from those and came up with this sign. When it's off, the logo and the letters are barely visible because they're 3D printed on the backs of those white panels on the front of the sign. When it's plugged in, I can use a browser on my phone to turn it on and off like this. And I can even adjust the brightness. I can change the colors. And I can even make it display various patterns. So for example, we could make it a blinking rainbow or a candy cane. There's a whole host of different things that we could do with this. And you can even hook it up to some smart home devices like the Amazon Echo if you really wanted to. So in this video, I'll go through the parts that are needed for this sign, how to set up the Node MCU to control the lights, how to put together the wiring for the project, how to customize those sign panels, and finally, how to put it all together to create your own version of the sign that you see behind me. For this project, we're going to need the following parts and supplies. First, some filament for your printer. I went with Overture's white PLA for the panels and Sunlu's blue PLA for the frames themselves. For the lighting, I've used a string of WS2812B 5-volt individually addressable LEDs. These were spaced at 17 millimeters per pixel. This is somewhat important because the frames I designed are specifically for lights at that spacing. Controlling everything will be an ESP8266 Node MCU microcontroller. What I liked about this particular controller is that it was Wi-Fi built right onto it. So there's no need to add an external Wi-Fi adapter. Moreover, there's already software out there specifically for controlling lights like this, which makes setup super easy. We'll also need a 5-volt power adapter. I'm with one that is 3,000 milliamps to ensure I have plenty of juice to power the board as well as a large number of the LEDs. You'll also need a corresponding barrel power supply socket that fits your adapter. We'll need some basic wiring supplies. First, we'll need one integrated circuit, 74HCT245. This will convert the power coming out of our microcontroller's pins from 3.3 volts to the 5 volts needed for our lights. We'll also need a single 220 ohm resistor. All of that we mounted on a perf board that is 3 centimeters by 7 centimeters and has 10 holes by 24 holes in size. I'll put a link in the description for where I got mine. We'll need several lengths of wire. Specifically for your first frame, which contains the controller, you'll need 3 lengths of wire that are about 70 millimeters in length to run from the microcontroller to the first string. After that, for each additional frame, you'll need 3 wires at approximately 206 millimeters. I had 6 frames and was concerned about flickering, so I injected additional power on frame 4. Not sure it was needed, but I did it. As a result, I needed an additional 2 wires at around 700 millimeters, which was long enough to go through the 3 frames and still have extra to connect to the power coming in from the adapter. Lastly, you'll need 2 wires long enough to go from your barrel connector into your microcontroller. This length will vary based on how you decide to mount your connection. We'll also need some solder and shrink tubing for some of the wiring. Additionally, we'll want some glue to hold some of the parts together. To hang it, you'll need some picture hanging hardware on the back. Make sure you get something that is going to be strong enough. For reference purposes, my finished sign weighs about 12 pounds. Lastly, I mounted mine on wood. I used a wood board that's 12 inches wide by 1 inch thick. Sorry to mix metrics and standard US measurements, but that's how wood is sold where I'm at. I cut it to length such that my sign was centered on the corners and had about the same amount of wood showing on each side. I simply painted with some red spray paint and applied a gloss coat. If you use a wood back, you'll need 2 No. 6 1/2-inch wood screws per frame. On the tool front, we'll need a few things. First, of course, we're going to need a 3D printer. I'm using my Ender 3 V2 for this particular project. We'll also need a soldering iron and a heat gun to deal with the wiring and shrink tubing. Since I used wood, I needed to drill some drill bits to drill a few holes. I use a 16th inch drill bit for the pilot holes for the wood screws. Also need a screwdriver for screwing everything together. You could possibly use your drill to screw them in, but I prefer to do it by hand so I don't over tighten them against the plastic. Lastly, we're going to need some software. First, we'll need the WLED project, which we will flash onto our Node MCU. We'll go into detail on how to set this up in a little bit. Next, we'll need some kind of 3D design software in order to edit the STL files I've provided. You'll need to do this in order to place your own logos or images on the backs of the lighted panels. You'll need a slicer of your choice to slice the files and print them on your 3D printer. As usual, I'll be using Cura for this. And lastly, well, not absolutely required, it could be helpful to have a vector graphic design software. This will make it easier to convert your images to a series of edges or vertices for the back of your lighted panels. I'll show you how to do this using Inkscape. Yeah, there's quite a bit involved with this project, but we can do it. I put a link in the description to a lot of the products that I use as well as to the software. Now please note that none of the products or software that I've mentioned have sponsored any portion of this video. This build is going to require some customization of the files I provided on Thingiverse. So first things first, go grab all the necessary files from Thingiverse using the link in the description. Now you'll notice that all the lighted panels are blank in the files. If you want just blank panels, then go ahead, just skip this next part. But if you want to customize them like I did, we're going to need to head over to our computer. In order to customize our blank light panels, we'll need to open up FreeCAD. So go to File, Import, and choose our blank panel. This is just a mesh at this point, and so there's not much we can do with it. So we need to convert it to something that's more usable. To do that, we'll click on it, we'll go up to Part. This is all within the Part workbench, and we'll create a shape from the mesh. Just leave that default. Next, we'll collect that new one. We'll convert it to a solid. And lastly, we'll refine the shape because that'll make it a lot easier to work with later on. We can then get rid of these top two by selecting them and hitting delete. The next thing we want to do is make this part of a body. So we'll come to the Part Design workbench. With it selected, we'll choose Create a New Body and make it active. And you can see that's now part of the active body, which is helpful. At this point, we have a few options. If we want to create our design within FreeCAD entirely, we can then just choose our panel center here and choose to create a sketch on it. We could then, for example, just make a couple of circles like so. And then we'll go ahead and close that out. And with that sketch, we could then pad it up. The extrusion height we want for this is 2.8 millimeters. That seems to be about a good height to have a good shadow show up on our panel when it's lit. So we'll go ahead and hit OK. And at that point, you can see we have our extrusion. The other option that we could do would be to take and add a custom image to this file. So let's talk about how to do that using Inkscape. So we'll leave this here for the moment and flip over to Inkscape. What we could do is let's take a sample image, something that's probably a little bit too complicated to do in Sketcher. So we'll go and open that up, and it's just a PNG bitmap that I have. We'll embed it into this file. Nothing too fancy, but more than we want to do in Sketcher. What we'll want to do is trace this bitmap. So select this, go up to Path, choose Trace Bitmap, and we'll go ahead and apply. And that's created this second image here. So let's get rid of that first one behind it, and then go to Edit and Resize Page to Selection. At this point, we're going to save this as an Inkscape SVG file. We'll just call it Sample Image here. Just overwrite what I had there before. Now we can go back into FreeCAD and bring that into FreeCAD. To do that, we'll go Import again, and we'll find that sampleimage.svg file. Again, we'll want to make sure that when we import this, we do it as SVG as geometry and not as a drawing. So we'll make sure that's selected. And now you can see that we've added our image here. Let's adjust it a little bit. I actually like to raise it a few millimeters up above on the z-axis. And then I find it helpful to go ahead and get it centered using this placement tool. So just adjust the X and Y values until you have it mostly centered. Now at this point you might need to resize it. So for example, if I used it right now, it would be hanging off the edges, and that's no good. So we'll go ahead and hit OK here when we have it located where we want. And we'll flip over to the draft workbench. With that selected, we'll come up to Modification and choose Scale. Click on this Enter Point button, and then here we can adjust the scale. Since I want to make it smaller, I would change this down to, let's say, 0.7, making sure uniform scaling is selected. And you can see that that looks like it's going to be in the right ballpark. If, for example, I wanted to make it larger, my image was too small, for example, I might go 1.5. Or 2 or something larger like that. But for this, 0.7 is what we need. So we'll hit OK here. And we'll go ahead and hit spacebar to hide. Now what we need to do is convert this to, again, something more useful for us. We want this to actually be a face so that we can project it. To do that, we'll upgrade the shape. So with this path 664 here, the one we just created selected, we'll upgrade it until it says face. Once it says face, we can then come back to the part workbench and we'll choose this projected edges, wires, or faces of one object onto a face of another object. So we'll select that. We'll select the projection surface. So click on that and then select where we want the projection to be. So that's that surface there. Next, we need to select the face that we want projected. In this case, it's our object. Now, it's important that you be in the top view. That way it projects perfectly straight onto your object. If you're off to the side at all, it will project and lead to weird results. Lastly, we need to change the extrude height. And again, that's going to be 2.8 millimeters. We'll hit OK. We'll hide that face. And then when we come down here, we can see that we have now projected that surface at 2.8 millimeters onto the face of our panel. So we can come holding down Control and select those two items, and we'll come over here and we'll do make a union of several shapes. Lastly, we'll click on that and convert it to a mesh that we can then export and print. So go to the Mesh Design workbench, Meshes, and create Mesh from Shape. Leave this as the default. And then let's give this something a little bit more useful as a name. Odd Panel Test. And then we'll right click on it and export our mesh. And we'll just leave it called Odd Panel Test. So we'll come over to our slicer. I'm using Cura. And we'll open our Odd Panel Test. And you can see that we have our panel here. It takes up a lot of the build plate on an Ender 3. We'll need to make a couple of adjustments to this. First, we want the infill density to 50%. I know that's high, but the reason we need it that high is so that this middle part is dense enough that light doesn't just pass through it. Second, we need to change the infill pattern. As you can see, with the grid, it's going to allow too much light to get through. I found that the gyroid tends to block the light quite a bit, so that it makes a lot more sense. With that, you're ready to go ahead and slice and get printed. Now that we have our panels designed, let's get everything printed. For each sign, you'll need to print one of each of the end frames as well as one end panel. Then you'll need to print as many middle panels as required. For me, I'm making a 6-panel sign, so I'll need to print 4 of those middle frames. In addition, for each frame of your sign, you'll need to print 1 inner guide, 1 inner plate, and 1 light panel that you customized earlier. On the light panels, if you're using a glass build plate like the one that comes with the Ender 3, consider flipping it over and using the smooth glass side. This will give you a nice, smooth, shiny face on your light panels. Now, whatever you use, pay careful attention to your first layer on the panels, because it is your first layer that will be what everyone sees. Any flaws in that first layer will be accentuated by the life behind it. So if your first layer isn't perfect, stop your print, try again. Now for the frames, you'll need to print them with supports touching the build plate. But you can set the overhang angle really high. The only thing that needs support should be where the inner guides fit. Everything else is chamfered in such a way that it should print without the need for supports. The one exception is the frame end that is wire. That definitely needs support. I use Cura's tree supports for this. If you're using a 220 by 220 build plate like comes with the Ender, you can't print with a brim or skirt or a raft. The frames are just barely under 220 millimeters. I couldn't get Cura to slice it at first, as it said they exceeded the build plate size. To get around that, I actually changed my printer properties to make it 1 millimeter wider in each direction. Doing that allowed it to print. So yes, it will fit on a 220 by 220 build plate, but you might have to fiddle with it a bit to get it to print. Lastly, you'll need to print joints. The number of joints you'll need is determined by doubling the number of frames you have less 1. So I have 6 frames, I subtract 1 to get 5, I double that, thus I need 10 joints. So let's get all those printed. Once you have all of your parts printed and everything's gathered, it's time to start building. I like to start with setting up WLED on our Node MCU. So let's head over to the computer with a USB cable that fits in our Node MCU. The first thing we need to do is install the program WLED onto our Node MCU. The easiest way to do that is probably going to be going to install.wled.me, making sure that your Node MCU is plugged into your computer with a USB cord, and choosing install. You'll come up and choose COM9 or whichever COM port your WLED is connected to, and hit connect. If it comes up with that saying the serial port's not ready, go ahead and give it another try. Then choose install WLED and choose install. Hopefully this will work for you. The reality for me is a little bit different. I've never actually been able to get this work. I've seen other videos where this has worked just fine, but don't fret if you're in the same position I am. There are other ways of doing this. So let's go ahead and close this installer. If you go to the WLED project's knowledge base, you can come down here and you'll see this flashing method 2 using ESP tool. This has actually worked quite well for me. You can follow all the directions on here, but the first thing you want to do is install the latest release binary file. That's 0.13.0. I have downloaded a prior version because I don't usually use the beta, and the current stable version is 0.12.0. When you choose it, make sure you choose the one that says ESP8266.bin. Once you've downloaded that into your downloads file, you're going to want to open up your Windows terminal. You need to make sure that you have installed Python. Once you have Python installed, you need to install the ESP tool. You'll do that using python-m pip install ESP tool. And then after you've done that, you're going to want to change directories to where you downloaded the bin file. For me, that was CD downloads. And then we'll install that onto our Node MCU using esptool.py and the terminal line that it gives us. We'll go ahead and choose to do that now. And it'll take a couple moments as it has to write everything to your Node MCU. Once everything is installed, it should look like this. If for whatever reason you've had problems, I found the information on the WLED site to be incredibly helpful to solve any problems I've come across. So we go back to the getting started, and it says we need to connect to the access point that we just created using that node MCU. So we'll come over and connect to the WLED access point, which is now an option for us, and we'll hit connect. We'll give it a moment as it gets us connected, and then once connected, it says we need to go to the IP address 4.3.2.1 on our browser. So we'll go ahead and do that now, 4.3.2.1, and that'll take us into this screen. Now you might get something that actually looks like Wi-Fi setup your first time coming in. And if that's the case, what you'll need to do is provide information for your node MCU to connect to your local Wi-Fi network. You want to put all of this information in because it's going to make it much easier to access your lights through your phone. So go ahead and give it access to your Wi-Fi SSID and put in your password. And I like to give it a name. So I'm going to call ours sign.local. And then go ahead and make a note of that so you don't forget what that is. And we'll do save and connect. Once we've done that, you need to press the reset button. That's the one to the left, little button to the left of your USB on your node MCU to reset your node MCU. Once you've done that, you can then go in and do sign.local, and it will take you into WLED. There are a couple other things I like to do before I do anything further. The first is set up my segments. For each one of our signs, there are 44 individual LED lights for each frame. So if you have 6 frames, for example, then you would have 264 individual LED lights on here. So let's go first over to LED preferences and tell it that we have 264 lights. Make sure your LED voltage is the 5 volts because that's what we're using. So we'll go ahead and save that hardware setting. We'll go back and then we'll go back into the config. Down here to segments. And we're going to want to set up all of our segments. So we said we had 264, but we want to have each frame have its own segment. It'll just make setting up some of the things easier and playing around with it easier later on. So we'll set our segment 0, starting LED is 0, and ending with 44. And you can see that it's got 44 LEDs on it. And we'll go ahead and hit that. Then we'll go through and do that for all of them. Each will be a total of 44 LEDs. So 44 to 88. So when you look through any individual segment, you'll see that it has 44 LEDs. And again, you may have more or less segments depending on how many segments or frames that you have in yours. You can then, if you wanted to set up any presets, colors, anything like that, but it's in here that you'll be able to adjust your lights as well as adding any effects that you like. Once you have this setup done, you're ready to get everything, all the wiring and the soldering done. Once we have WLED loaded on our node MCU, it's time to start the process of wiring everything together. We'll start by putting our LEDs to length. For each frame, you'll need a length of light that is 44 LEDs long. Just make sure to cut in the middle of the electrical pads. Then we will attach our already cut to length wires. Remember, the first wires coming into the LEDs will be shorter at only around 70 millimeters, as they are only going from your node MCU to the string. You'll need to tin the ends of each wire, and then you'll want to put a blob of solder on each of the 3 electrical pads on the lights. I like to use the same color all the way down the string to keep things simple. I use red for the voltage in, black for ground, and green for the signal. Be sure that you start by soldering those shorter wires to the data inside of the LED strings. One end of the LED string will be data in and the other will be data out. If you flip it backwards, it will not work. On the wires on the data inside, I like to add a bit of heat shrink tubing. Next, take 3 of your wires that are the same length as your frames and solder them to the data outside of your first LED string. Once that is done, these wires then go into the data inside of the next string. Simply repeat this process until you've done all of your light strings. If you want or need to inject additional power into your system, then cut 2 wires long enough to go from the first frame to the frame you want to inject the power in. Then add at least 70 millimeters additional wiring. Then, when you get to that string, solder one of these long wires to the voltage in and the other to the ground of the string you want to inject the power into. The signal line comes from the previous string, and that will be the only direct connection between the 2 strings, the new one and the old one. You can then go back to normal wiring thereafter. Once you have the lights wired, it's time to go ahead and put your Node MCU on the perf board along with the integrated circuit. Follow the wiring diagram included in the Thingiverse files for the proper wiring. I made sure that the USB port on the Node MCU was facing out on the perf board. That way I can update it in the future if I need to. Once everything's soldered in place, clip away any pins on the Node MCU close to the perf board. Otherwise, it might not fit in the frame. When finished, one end should have 2 wires coming out of it. This will be the power comes in from the DC adapter. The other side should have 3 wires. One for the voltage, one for the ground, and one for the signal that goes to the lights. Now, solder the lights to the perf board, leads that you left in the prior step. Be sure that when you do so, you wire it properly so you're connecting the voltage, ground, and signal properly. I like to add some heat shrink tubing to these connections. Lastly, we'll solder the wires onto our barrel connector. Make sure you are aware of whether your power adapter is center ground or center voltage. Then be sure you wire your barrel connector accordingly. So my adapter is center voltage, so I'll put a red wire on my inside and a black on the outside. Next up, it's time to put the frames together. Lay the frames down, line up the joints using 2 of the printed joints per pair of frames. Simply jam the joints in and push them in until they're flush. They'll be tight, but they should go in. Next, we'll glue on the guides to the back of the frames. Again, these should fit snugly, but they should also be flush with the back of the frames. Once that's done, it's time to start working on the wood. We're going to mount everything on it. First step is to cut it to length. You need to decide what you think looks good. I wanted mine centered, so I figured out how wide the board was and subtracted the height of the frames. I then added to that number the total length of the combined frames, and that was how long I cut my board. Once cut, you'll put the combined frames on your piece of wood and get them centered on your board. Once centered, you'll want to mark where the holes are in the edge of the sign where the Node MCU fits. You also want to mark each of the holes in your inner guide so you know where to drill your pilot holes. After everything's marked, put your frames off to the side and get out your drill. Find a drill bit that matches the diameter of your barrel connection. Then decide where you want the wire to come up inside the frame that you marked in the previous step. Measure that distance from one end of your board. You'll want to drill a hole on the face of the board down a little more than halfway through the board. Don't go all the way through the wood though. Next, flip the board on its end and drill a hole straight down into the board. This hole should be perpendicular to the hole you just drilled. If you measured it out right, the two should intersect at a 90-degree angle. Be careful to go slow on this step and go in perfectly straight. You don't want to pop out of the side and mess your wood all up. Once completed, you'll be able to pass wires cleanly through. Next, go ahead and drill the pilot holes for your inner guides. If you use the number 6 wood screws, you want to use a 1/16 inch bit. Again, go slow. With these thin bits, if you aren't paying attention, you can snap it off in your wood. Now go ahead and flip your piece of wood over and install your hanging materials. It's easier to do this now before you put your frames on. If you wait, you're much more likely to be pushing down on your finished frames or attaching the hanging material at an odd angle. I know this from personal experience. It wasn't fun. At this point, it's time to go ahead and finish your board. I painted mine, but you could stain it. Do whatever finish you like that makes you happy. Once everything's dry, let's start by running the barrel connection wires through the hole and then putting it in place. You might need to screw it in a little. Just make sure it's snug with the wires. Take your time, bring them up through the holes you drilled. Now, bring your frames back over and put them in place. Make sure your wires go up through the holes in your end frame. Then you'll go ahead and screw the inner guides down using the wood screws, being sure to line everything up with the pilot holes that you drilled. This will help ensure that everything is properly lined up and centered on your board. At this point, it's time for the final soldering. Once the frames and the barrel connection are in place, we can connect the barrel connection wires to the end of the perf board. Once that's completed, we can finally put the soldering iron away. Now we need to install the inner panels. These thin panels are important because they help reflect the light up and in the right direction. Without them, the light panels would be rather dim. These are tight to get in. You'll have to flex them some. Don't worry, you can flex them and they won't break. They also fit rather tight around the inner guides, so you need to push the panel around those side guides to get them to sit flat. Mine were tight enough that I didn't even need glue to hold them in place, but feel free to add a little if you think it's needed. Now for the process of stringing the lights. Starting with the far end of your light string, pass it through the hole on the side of the frame and above the white panel. Gently pass it all the way through each frame until you get to the last panel. Take your time. You do not want to mess up any of the soldering on the lights by pulling too hard. Once you get down to the last panel, I found it easiest to put a 90-degree bend every 11th light. This will mark where the corners go. Then you can remove the backing and expose the adhesive on the back of the lights. Starting on the same side of the frame right next to the hole where the lights came in, work your way around the panel, pushing the lights in behind the guides and flush up against the inner light panel. Again, take your time. The little guides on the side help keep it in place if the adhesive were to come loose. They are also spaced out so that they should fall in between two lights and not where a light actually sits. Now the first panel is the easiest because you don't have any extra wires to work with. With the middle frames, you'll need to pull through a whole set of lights and bend them as before. But this time, you'll have at least 3 wires to work around. I found it easiest to push them down into the side guides and then start putting the lights in place. Again, start in the corner with the hole where the lights come in to the frame and work your way around, pressing everything into place. Once you get to the last side with the wires, just make sure the wires are being held in place by the lights. If not, they could float around and potentially cast weird shadows on your panel. Then, you just repeat this process for the rest of your panels. Again, I can't stress this enough. Take your time, it's not a race. Once the last lights are in place, it's time to put the Note MCU into place. I put it on the side with the power coming into it. It was actually on the far side of the frame from where the power came up through the wood. So I had to run the incoming wires underneath my board. Make sure all your lead wires on the perf board are in the middle and press the perf board into the holder built into the frame. It's a snug fit and it really kind of holds itself in place. Then if you have any extra wires, wrap it all up, push it into your frame. Now you're ready to install the cover panel, being careful that all the wires are inside and not being pinched. Go ahead, plug it in, make sure the lights work. As you can see, the LED on the board is rather bright. I don't mind it because I like being able to see that it's on. But if it bothers you, you can just cover the LED up with a small piece of electrical tape. Lastly, it's time to install your light panels. Make sure that you have them oriented correctly relative to the frames, then push them into the grooves of the frame. You might have to push hard in the corners as they are a tight fit. Again, mine were tight enough that I didn't need glue, which is what I wanted because I wanted to be able to replace them easily or take them off if I needed to fix the lights in the future. And that's it. Your own Nanoleaf inspired sign. Find a fun place and hang it up. Set up any timers you might like in the WLED browser page. This project took me a while. I struggled in figuring out how to design the frames, and I appreciate the time my brother-in-law spent talking with me about them to come up with a plan that worked. Were I to redesign things, I'd probably build those inner guides into the frames themselves. But I wanted to give people the option of just gluing the frames to a board if they really wanted to and not waste plastic on the inner frames. This was a fun project, even if it did take a while to design and build. I'm really happy with how it turned out, and while it isn't a waterfall, I hope our secretary likes it. As always, if you found this helpful or interesting, I hope you'll like and subscribe and leave a comment. I look forward to seeing you in the next video.